All right, guys, it's math time tonight. Woohoo! So let's take a look at lesson 96. It's functions and graphing functions. Don't let what's on the board get really big and bad and scary because it's really not. So let's take a look at our new concept. Our new concept is the surface area of a rectangular prism is the sum of the areas of its sides. A cube is a special rectangular prism with 6 square sides. If we know the area of one side of a cube, then we can find the surface area of the cube. So if we look at our purple graph up there, we can see the area of a side is 4 centimeters. And we look over at the surface area of the cube and we see 24. So we look at that and kind of go, well, 6 times 4 would equal 24. Then we're going to look at our next number, 9. Does 9 times 6 equal 54? It sure does. Then if we look at 16, multiply 16 times 6, we should end up with 96. And 25 times 6, we should end up with 150. So with this concept, we just have to do some calculating is what we have to do in order to find out what is our pattern. Really super easy. So let's take a look at example number 1. It says find the rule for this function. Then use a rule to find the value of m when I is 7. So if we look at the graph and study it to discover the function rule, we see that when I is 5, m is 20. We might guess that the rule is to multiply I by 4. However, when we look at 25 and 10, we know that that's not the case because 10 times 4 would equal 40, not 25. So we look at the values at the bottom of the row and see I equals 15 and m equals 30 at the very bottom. Everybody see that one down there? Perfect. So we go, well, if I add 15 to 15, that's going to give me 30. If I add 15 to 10, that's going to give me 25. And if I add 5 and 15 together, that's going to give me 20. So let's see if it'll work for 7. So I take to find m and add 15 to I. So I equals 7. That's our equation. Perfect to find m. All right, we have I right there looking at 7. So we replace the I with 7. So 7 plus 15 will give us m. And if I add that together, I'm going to see 7 plus 15 equals 22. Woohoo! So 22 is our example. Now, you might have to start at the bottom like we had to at that one because 5 and 20, yes, the first thing we would think of would be 4. But if we worked from the bottom up, that's when we noticed that it was actually adding 15 to that. All right, let's take a look over at example number 2. Find the missing number in this function table. Now, this is an equation, just like we've had throughout the year. You have to make sure and follow the equation in order to find out what you are doing. All right, so if we look at it, we have 3x minus 2 equals, well, I'm going to replace the x with 2 to begin with. So 3x, so 3 times 2 minus 2 would equal 4. Woohoo! That's exactly what we have on number 2. If I take the same equation and use 7, 3 times 3 equals 9 minus 2 equals 7. Exactly. Now let's see if we can get it to work for 4. So 3x, again, 3 times 4 equals 12. 12 minus 2 equals 10. Woo, woo, woo. So 10 is our answer on that one. So again, write your equation just like we've been doing every single time. Then take your x, which is your variable, and replace it with the number they're giving you, and then work the rest of the equation. Very super easy. All right, moving on to example 3. And I think Kaylee is going to have a really cool joke for us here in a minute. But we're going to go ahead and work example number 3 right now. So example 3, now we've got a graph up there. Oh, wow, that's going to be different. But you know what? It's going to still be fun. So let's take a look at example 3. The perimeter of an equilateral triangle is a function of the length of its sides. Make a table for this function using side lengths of 1, 2, 3, 4, 5, 6. So we're going to use the bottom 0 to 6 is going to be our length of the side. So we label that length of the side. Excellent. And then we are going to use 0 through 24, although we don't have to necessarily go through 24. We have up through 15 on this one. And that's going to be the parameter of our side. So as Kaylee's writing that, we see on the board, we had a graph that said S and P. Perfect. And it's not sausage and peppers. It's a side and parameter. So we're going to graph this now. So now we have to graph these points on a coordinate plane with one axis for parameter and the other axis for the side length. We've already established that. Then we draw a ray for the origin through the points. So we have 1 and 3. So we go over 1, up 3, put a dot, perfect. 2 and 6, over 2, up 6. Perfect. What do we have? 3 and 9. Can you go to the side? We can't see. Perfect. And then 4 and 12. Go over 4, up 12. Awesome. And then we're going to draw a line through that, stating that it extends through this line. So very easy on that. We just make sure that they're in a line, kind of a little lopsided, but if you use an actual ruler, you can get them really well with that. All right, so that is our examples for the evening. You are going to need to do practice set A, B, C, D, and E. A, B, actually all 4 of them, you're going to have to find the X, the Y, or the A, the B, the equation like number 2. So you C and D are just like number 2 on that. And then it wants you to graph E. So E says the chemist mixed a solution that weighed 2 pounds per quart. Create a table of ordered pairs for this function for 1, 2, 3, and 4 quarts. Then graph the points. All right, so your quarts, 1, 2, 3, 4, will be your x-axis. So it will be the bottom one. And then you are going to graph it by making your graph just like example 3 has there. S and P, and then graph it. All right, let's see if Kaylee's got her joke for today. And she's not going to tell you the answer. You're going to have to write it down because then we'll see if you get it right. So, drum roll, please. And Kaylee!
Why was the math book always worried?
Ooh, why was the math book always worried? Because it was rocket science. Oh, man, that's the wrong answer. All right, you guys get the answer. Put it on the top of your paper and put up their joke, and we'll see if you get it tomorrow. All right, y'all, have a great evening. We'll see you tomorrow.